Today we're joined by Demis Hassabis, who's the CEO of Google DeepMind.
We're pretty much releasing something every day. It's hard to keep up, even internally.
I feel like we're shipping lots of stuff. DeepThink, IMO Gold Medal, Genie 3, which is, the reception has been super incredible.
We want to build what we call a world model, which is a model that actually understands the physics of the world.
Building the technology and then also actually putting it into people's hands is like such a beautiful combination.
We're starting to see sort of convergence of those models together into, kind of what we call an omni model, which can do everything.
So we also announced our partnership with Kaggle to launch Game Arena.
As the name suggests, the best models get pitted against each other. As they get better, the test will get harder automatically. And I think it's just one of probably many new benchmarks that are going to be required as we get closer to AGI. It's an amazing, exciting moment in the industry, I would say.
Hey everyone, welcome back to Release Notes. My name's Logan Kilpatrick from the Google DeepMind team. Today we're chatting with Demis Hassabis, who's the CEO of Google DeepMind. Demis, thanks for being here. Excited to chat about all of the releases and progress that we've had in the last few months.
Great to be here.
Let's start with just the unprecedented amount of momentum. I feel like we're shipping lots of stuff. DeepThink, IMO Gold Medal, Genie 3, which is, the reception has been super incredible. Like 50 other things in the last 2 months that I feel like we've already forgotten about because things are moving so quick. I'm curious to just like get your high-level sense of that progress and momentum that's happening.
Yeah, it's fantastic to see. We've been sort of building up to the speed, I think, of our shipping and progress over the last couple of years, and I think you're seeing the results of that now. But it's an amazing and kind of exciting moment in the industry, I would say. Seems to be, things coming out every day. We're pretty much releasing something every day. It's hard to keep up, even internally, and the field as a whole. So, it's exciting to see, and I'm really proud and pleased with, some of the latest work we put out there.
Yeah, how are you thinking about DeepThink specifically? Obviously, one of the things I've been most excited about is like the model's actually available to a version of the IMO Gold model is available for Gemini app subscribers. People can actually like put their hands on the model, which I think has historically we were opinion about Genie stuff, and like I think that's like building the technology and then also actually putting it into people's hands is like such a beautiful combination.
Yeah.
So from a DeepThink perspective, how are you thinking about it?
Well, look, I think these, the advent of the thinking models is a little bit a hark back to our original gaming work on things like AlphaGo and AlphaZero. So we always worked on, from the beginning of DeepMind, actually, the history of our work has always been with agent-based systems. So what we mean by that is systems that can complete a whole task, right? Mostly in the early days, playing a game really well. And there's an objective, and you basically, you have this model, model of, today we have multimodal models, really powerful ones that model language and everything around us. But in those days, we would have gaming models, and then you need some thinking or planning or reasoning capability on top. And this is obviously the way to get to, AGI. And then, of course, once you have thinking, you can do deep thinking or extremely deep thinking, and then sort of have parallel planning you can do sort of planning and thoughts in parallel, and then collapse onto the best one, and then make a decision, and then move on to the next one. There's still, I think, quite a lot of innovation that's required there, but it's exciting to see the rate of progress, even in the thinking part of things. And obviously for things like maths, for coding, for scientific problems, also for gaming, you're going to need to process and plan and basically do this thinking, and not just output the first thing that the model comes up with. That's unlikely to be good enough. So you want to sort of go back and refine your own thought processes, which is in effect what the thinking systems do.
Yeah, I had not seen the thinking game, and I watched it probably a week and a half ago or something like that. And I was scribbling down notes as I was watching, and I was like, "Wait, Demis and the DeepMind team were ahead of all of this stuff." I was like, there's so, and also there's just so many interesting parallels to like, as you were trying to scale up RL to solve like previous problems, like what that looks like today, and like the like data bottleneck for AlphaFold is a good example, and like similar to like how we have that problem today with like human expert data for some of these domain specific tasks like coding or just like outside of scientific domains. How much of that do you like? Does it feel like deja vu as we're like now solving these problems with language models and scaling up in other domains?
Yeah, I think we were always on the. I think it's sort of become clear we were always on the right track with we were the first to sort of use RL seriously. Basically, that was one of the first bets we made back in 2010, along with deep learning. And of course, our Atari work, which was the first thing, our first sort of landmark result, was the first real deep RL system that could actually do something interesting and useful. In that case, play, Atari games from the 1970s just from the pixels on the screen and be better than any human can play it. But importantly, play any Atari game, right? So out of the box, so it's sort of generalized, and that's really what I think sort of proved to the field that these new techniques were ready for to be scaled up and actually be useful. So we've always had this kind of thing in mind, and thinking is something. If you play chess like I did when you're very young, you kind of that's all you're thinking about is how to improve your own thought processes. How does your thought process work? And of course, that leads, at least for me, led me to thinking about neuroscience, how the brain works, and then AI as this amazing tool, and also try to distill intelligence into a digital artifact. And there's still a long way to go. The kinds of systems we have today, they're very good at some things, but they're still pretty flawed at other things and relatively simple things. So they're impressive. They can get gold medals in IMO, which is unbelievable, really, if you think about it, just from the natural language description. And by the way, these are just Gemini models with deep think and a bit of extra thinking. They're not specialized around these tests, and yet they're really really good. But on the other hand, they can still make simple mistakes in high school maths or simple logic problems or simple games if they're posed in a certain way. So that must mean there's still something kind of missing. And these are kind of, uneven intelligences or jagged intelligences. Some dimensions they're really good, other dimensions their weaknesses can be exposed quite easily.
Yeah, I want to come back to this, but actually before we do that, can we double click on Genie 3? I think there's an interesting segue around models aren't great at playing games, and yet I saw a bunch of people commenting on Genie 3, and the reaction was like absolute awe. Like people are like, this is, I saw some very extreme comments being like, we're in a simulation. Like
Yes.
this is like proof that like anything is possible because the Genie demos are so good. So how and it also obviously ties to solving RL with games. Like how much, if again, if you had to look back and then now reflecting on like the Genie 3 moment, do you think like has that turned out how you would have expected? I feel like it's not obvious to me that like making models good at playing games results in the world model stuff that we have
Sure.
today.
Well, there's several. It's sort of Genie is several branches of kind of research and thinking coming together, ideas coming together. So, on the one hand, we've used board games as a challenging domain for to improve our AI algorithm ideas. We used to use computer games a lot for both as challengers, but also to create synthetic data. So we used to, we still do use a lot of simulated environments, very realistic ones, traditionally built ones, actually, like 3D game engines, to create more training data for our systems to understand the physical world. The reason we're doing that is we want to build what we call a world model, which is a model that actually understands the physics of the world, right? The physical structure, how things work, materials, liquids, and even behaviors of living objects, animals, human beings, right? How that's obviously a critical part of our world. We don't just live in language and maths. There's the physical world that we exist in. And so if you want, an AGI clearly needs to understand the physical world, partly also so it can operate in the physical world, whether that's robotics. I mean, that's what's holding robotics back. It needs a world model, or things like Project Astra, our Gemini Live project about having a universal assistant that can assist you in everyday life, maybe exist on your phone or on glasses, and help you in your everyday life. Clearly, that also would need to understand the spatial temporal context that you're in. So you need a world model to really understand the world and how it operates. And that's one of the ways to prove that you've got a good world model is to be able to generate the world. So there's many ways to test the efficacy and the depth of your world model, but one great way to just is to just get it to reverse it and sort of generate something about the world, like a you turn on a tap and some liquid comes out of it, or there's a mirror and can you see yourself in the mirror? All of these things, and that's what Genie sort of going towards is. Building that world model and then expressing it and actually be able to generate worlds that are consistent. And that's the surprising thing about Genie 3 is that you look away, you come back, and that part of the world is the same as you left it, which is mind blowing, really. And it shows that it has a very good underlying model of how the world works.
How do you think people will use Genie? Is it like is the intent for us to just like leverage it to help make Gemini and some of our other like robotics initiatives like better and scale that up? Or like do you think there's actually like obviously like maybe the I could see people playing with it in
Yeah.
some cases, but do you think there's any like
Yeah, it's so exciting in multiple dimensions, which is that one, of course, is we're already using it for our own training. So we have a games playing agent called Simmer, simulated agent, that can out of the box sort of take the controls and play an existing computer game, right?
Mm.
In some cases, well, in some cases, not so well. But actually, what's interesting here is that you can put that Simmer agent into Genie 3. So you've got basically one AI playing in the mind of another AI. It's pretty crazy to think about. So Simmer is deciding what actions to take and what you can give it a goal, like go and find the key in the room, and then it will sort of send out commands as if it's playing a normal computer game. But actually, at the other end is Genie 3 generating the world on the fly. So there's one AI generating the world, and there's another AI inside of it. So it could be really useful for, of course, for creating sort of unlimited training data. So I can imagine that being very useful for things like robotics, but just training our general AGI systems. But also, of course, it's got a lot of potential in an applied sense too, for the future of interactive entertainment. I've got many ideas, as you wouldn't be surprised, of what types of next generation incredible games can be made. Um, and maybe some new type of entertainment that we haven't really thought of before, that's somewhere between film and game, some new genre of entertainment. And then finally, maybe the most interesting thing from my point of view as a scientist is, what does this actually tell us about the real world and
Mhm.
physics, and maybe things like simulation theory? One has to, when you're working on this like late at night and you're sort of generating these entire worlds and you're sort of thinking through how this technology is working, you have to sort of also consider, and I've always been doing that in my career, of like, well, what's going on in the real world? What's the nature of reality? And actually, that's the thing that's driven me through my whole career to build AI as this amazing tool for science. And I think things like VO3, our video model, and video audio model, and Genie 3 really tell us something about the nature of reality if we look at it with a slightly different lens.
Yeah, I love that. I think this is actually a perfect transition to what you were saying before about jagged intelligence. And on one hand, we have this like mind-blowing system where the worlds are being generated and all this stuff. On the other hand, you take Gemini out of the box and you ask it to play chess.
Yeah.
And like I was telling you off camera, like I'm terrible. I know the rules of chess, but I'm not actually good at it.
Yeah.
And I think I could beat our models at
Yeah.
chess right now. So how do you, and in some cases, like they can't even follow the rules. So we also announced GDM's partnership with Kaggle to launch Game Arena and have the models have a place to go and play a bunch of different games and test out the capabilities. I'm curious to get your reaction to that.
Well, look, it's really interesting. So this is a wider thing of like, okay, so now all of our systems, ours, Gemini, but also our competitors, are getting better and better. Um, our systems can do some amazing things. Generate simulated worlds from text prompts, understand videos, all of these cool things, solve maths problems, do things in science. But we all, I think, intuitively, all of us have played around with these chatbots, and you see the edges of what they can do quite easily, right? And in my opinion, this is one of the things that's missing from these systems being full AGI is the consistency. It shouldn't be that easy for the average person to just find a trivial flaw in the system. It used to be counting the number of R's in strawberry, right? I think we managed to solve that now, but
Yeah.
they're not, there are some still pretty trivial things that these systems, like a school kid would trivially do that these systems can't. So why is that is a good question. There's probably some missing capabilities in reasoning and planning, in memory, that maybe one or two new innovations are still needed in those domains other than just scaling. Um, but it's also partly maybe we need benchmarks, better benchmarks to eke out what these things good at versus what they're not good at. And they're very general, these systems, but including Gemini, but a lot of the benchmarks we use are starting to get saturated. So, you look at some of the standard maths benchmarks like AMI, I think the latest result with DeepThink was 99.2%. So, you're sort of getting into the region of like the very diminishing returns, and there may even be an error in the test, and so they're getting rapidly saturated, and so we're in need of new, harder benchmarks, but also broader, in my opinion. Understanding world physics and intuitive physics and other things that we take for granted as humans, and we find easy, things like physical intelligence as well, actually, right? We don't have really good benchmarks for these things, and also some safety benchmarks too. Testing for traits that you don't want, like deception, things like this. So I think there's actually a really amazing work to be done in creating benchmarks that are really meaningful, that test slightly more complicated or subtle things than the sort of brute force school exam type things that we have today. And that's why I'm so excited about Game Arena, because and it is going a little bit back to our roots, of course, which is why we came up with it. But a lot of the reasons we started with games still hold today. So, firstly, they're very clean testing grounds, right? You get elos, you can get scores very easily. It's very objective. They're very objective measures of performance, right? There's no subjectivity, A/B testing with human beings just deciding the ratings and so on. I just think it's super scientific in that sense, right? The other thing is they automatically scale with the capabilities of the systems. So because the systems are playing each other in tournaments, and this is pretty fun to watch actually, even at this level that they're at. That's the whole point of Game Arena, as the name suggests, is that the best models get pitted against each other. So what we hope is that will actually drive a lot of progress, because the systems are, today they're none of the AI systems are very good at gaming, and things like chess, but even simpler games than that. That's an interesting question. Why is that? And I'm sure they'll rapidly progress. Now we have a measure for it with Game Arena. Um, but as they get better, the test will get harder automatically. So you don't have to. It's not like AMI or GPQA where you have to come up with harder science questions, and then who's going to create those questions? Are they leaked on the internet already? Each game is unique because it's created by the two players. So there's a kind of uniqueness about that. So that's also nice for testing. And then the final thing is, just like we did with our own early games work, as the systems get better and better, you can introduce more and more complex games into the game arena. So we started with chess, for obvious reasons. It's the classic one we test AI on. It's close to my heart, of course, but the idea is we're going to expand it to potentially thousands of games. And then you'll get an overall score. So we're not really looking for systems that just play one game really well. They should be able to play across all games to a good standard. And it could be computer games as well as board games. And even more interestingly, eventually, maybe the AI system should be inventing their own games, and then sort of teaching them to the other AI systems have to learn them. So it's like learning a new game. So it never existed before. So there's no way you could sort of overfit on training data or anything like that. So I have a lot of ideas of like these sort of multi-agent environments that eventually Game Arena could end up supporting. So I think it's going to be a really important benchmark that will kind of be long lasting. And I think it's just one of probably many new benchmarks that are going to be required as we get closer to AGI, to make sure that we've actually covered the space of cognitive capabilities.
Yeah, one of the big challenges, and this has been my reflection, and I want your reaction to this in the last couple of years, is that as I thought more about evals, it's become very clear that like actually most of life's problems are eval problems. And you don't think about this, like it's not unless you're doing AI and training models, like I don't, but I'm like, performance in your job is an eval problem. Like how you look at all these other things are all eval problems. And it is interesting that like we don't the like human equivalents of solving these problems. Like the game arena stuff is nice because like there is this empirical, like there's truth in that the system has all these constraints. But as we sort of extrapolate out, you sort of like I imagine outside of the game domain, like you lose some of this. Like I was thinking about like how do we make RL environments for all these other tasks that humans do as an example, and it becomes hard because it's like what is the source of truth in those
Yes.
cases? And I'm curious like for non-game environments, like like, how do we get to start to capture those things?
Yeah, I mean that's always been the hard challenge with reinforcement learning has been where in domains that are more messy or real world like, how do you specify the reward function or the objective function that you're trying to optimize? And I think in our world and as humans, we don't have single objective functions, right? It's very messy. In fact, if I was to tell you, what are you optimizing for? On any given day, you might give a different answer, right? And I think we're sort of multi-objective, and we're continually weighting those different objectives differently against each other, depending on other states like your emotional state, your physical environment, and where you are in your career, all of these things. So but somehow we muddle through, right? With our brains, and we sort of figure out roughly what the right North Star is. And I think there's our systems, our general systems, are going to have to do that too, where they sort of learn to interpret maybe what the human users trying to achieve, and then figure out how does that translate into a set of useful reward functions which to optimize against. And so there's lots of experiments here about going on about like metacognition or meta RL, where you actually have another system on top that tries to work out what the reward functions are for the secondary system to optimize against. And a lot of those things are still very much research problems. But I think they're again. We used to again research those maybe like 10 years ago when we were in the middle of our games work with AlphaGo, but I think and AlphaZero. But I think a lot of that is going to come back in now.
I feel like we should just start doing
Yeah,
it now because it feels like all the things that DeepMind was doing 10 years ago are
yeah,
now the like exactly whatever. Yeah, it's the
yes,
forefront of it's what everyone is
yeah,
trying to do. I want to back to this like thinking trend and also related to the game trend. We historically have had all these different like scaling dimensions of models. You have
yes,
scale pre-training,
yeah,
post-training. The data has been scaling up. The compute was scaling up. Then we had this sort of like reasoning scale up, which is a lot how a lot of the new like deepthink is
hmm,
enabled by reasoning scaling up. It also feels now like tools are this like new scaling dimension where as you give the models tools and more powerful tools and different tools, they're able to do a bunch of stuff. And I'm curious how that sort of new scaling dimension like ties to this worldview of what we've been doing with games and some of these simulated RL environments. Like, is there a world where you like give the model a physics simulator and like that's a tool that
yeah.
it has access to?
Yeah, I think tool use is going to be, and is one of the most important capabilities for these AI systems. A lot of the thinking, the reason the thinking is part of the systems is very important is because you can use tools during the thinking, right? You can call search, you can use some maths program, you can do some coding, come back, and then update your planning on what you're going to do. So I think that's still actually fairly nascent at the moment, but I think that's going to be incredibly powerful once that becomes really reliable and we work out and the systems become good enough, they can use pretty sophisticated tools very reliably. And then the interesting thing comes is what do you leave as a tool versus put into the main system, the main brain, so to speak. Now, with humans, it's easy because we're physically constrained. So anything that's not in our body is a tool,
Yeah.
right? So there's no question about what's a tool, what's our brain. But with a digital system, you can actually kind of those things can get blurred. So, should it be in the main model, the capability, for example, to play chess or something, or do you just use Stockfish or AlphaZero as a tool? And that tool could also be an AI system. It doesn't have to be a piece of software. It could actually be something like AlphaFold or whatever. And the question comes, I think, whether that capability helps other capabilities. So, for example, math and coding, we do put in the main model, the main Gemini model, because that seems to lift all boats, right? If you get good at coding, you're good at math, then your reasoning capabilities are just better across the board. And I suspect that may also happen with things like chess. But on the other hand, you don't want to put too much specialized data in your general model because that might harm other things. So it's very much an empirical question. Does adding that capability in help the other capabilities? If it does, then do it. If it harms the other general capabilities, then maybe consider using it as a tool.
Interesting.
Mm.
What one of the questions that developers, like through the developer lens of
Yeah.
like people who are building with our models are always asking is around sort of like it's become very clear, and you actually just said this, like as the model is reasoning, it's actually making use of tools and it's doing all this stuff.
Yeah.
The models historically were like weights. They were you give a token, you get a token out.
Mm.
Now it feels like the models are like becoming these entire systems themselves, and how people actually build applications on top of the models is changing because the model is just doing more for you out of the box. I'm curious, like that model transitioning from just being weights somewhere to like actually becoming a system, like resonates with your worldview of like how progress is happening. And we'll see that continue. And then, yeah, I don't know if you have like suggestions for people who are building stuff as they're like thinking about what do I build to this point of like what do I do as a tool versus like what is the model just going to have empirically as part of it.
Yeah, I mean, you're right that the models are improving fast, and as they're gaining the tool capability, it's sort of along with planning and thinking, it's kind of exponentially increasing what the system might be able to do because obviously it can combine tools in novel ways and combinations. I think one thing you can think about is like, what are the sorts of tools that are going to be incredibly useful for AIs to use, and start building those and providing those. So I think there's a lot of potential there. Um, the agent itself, even with tool use, is not necessarily enough to be a whole product. So there's still a lot of productization, I think, that has to be done on top. Now, the hard part, and we've talked about this before, is in this new world is you've got. I think it requires very interesting skills from a product manager or product designer type of role, because you've got to sort of design. Say your product's coming out in a year, you've got to be really close and understand the technology well to kind of intercept where that technology will be in a year's time and design for that, right? And I think and also whatever product polish you put on top of your product, it has to allow for the engine under the hood to be unplugged and plugged back in with a more advanced system, that's coming out every 3 to 6 months, basically, maybe even faster than
It
that,
feels
right?
like every
Feels
two
faster,
months.
yeah. Feels like every 2 weeks these days. So you've got to sort of take that into account. I don't think that's going to change. But I think this, thinking forward is about the whole web ecosystem and the way that apps work and things like that may change because of agents using these systems and being able to sort of use them as tools effectively.
Yeah, that makes a ton of sense. The progress for Genie 3 has been incredible. And I think people are losing their mind over the system that we currently have. I am hopeful. I'm going to keep pushing you of like, how do we get the how do we get the model into more people's hands? So hopefully that's coming. Lots of people are excited. I'm sure you've been getting pings from people being like, how
Yeah.
do I use the model? Where do we go from here from a world model Genie perspective?
Well, look, we of course we're trying to get it as efficient as possible now, so we can give it to many thousands of people. It's in sort of limited preview currently, but we're also thinking about what's the best way of releasing this as a user experience. Can we would love people to be able to share their creations with each other and allow people to play in the creations of other people and things that got voted up, a sort of like a user generated community in a way. And but the interesting thing is to maintain consistency, because maybe you capture lightning in a bottle at one point, you get some great prompt that creates a really compelling world. How do we make sure that we can regenerate that world for the next players to come in and experience? So there's a bunch of thinking around there. So there'll be a lot more information on that to come soon. And I think where it's going all together is, if you think about Genie, you think about VO, you think about Gemini. I think a lot of these are separate models currently, but we're starting to see sort of convergence of those models together into kind of what we call an omni model, which can do everything. And we think that that's what an AGI system should be able to do, is really handle all of those different aspects to the same quality level that we see with all of these different specialized models, but perhaps in one big model.
I love that. We were joking off camera about all the chess stuff and it just being a good excuse for us to go to play games. I feel like Genie's a good excuse for us to have a
To
chance
make games.
to
Yeah,
make
exactly.
games and play them, and then DeepMind's a video game
Yeah.
company. We
Well, that's always my secret plan, is maybe like post AGI, once that's done safely over the line, go back with these tools and make the greatest game ever. That would be a real dream come true.
Is it going to be a roller coaster simulator?
Yeah, maybe like the ultimate version of theme park, but I have some bigger game ideas in mind.
We're building a bunch of vibe coding stuff in AI Studio. So I feel like the ideal world is pre-AGI.
Yeah.
You can actually just start like firing off a bunch of these ideas, and we have a whole like Demis game arena that you build yourself.
Yeah,
Vibe
would love to try that out. That's something on my very high up on my to-do list, that's for sure.
I wanted to also, you and I had a couple of tweets going out about this last week, I think, or the week before. We were celebrating like 980 trillion tokens on a monthly basis. And I think we crossed the quadrillion mark. So we had something special made for you in your signature
Thanks
blue
so
color
much.
as well.
Whoa, fantastic. Awesome, awesome.
We'll get some
Yeah,
derivatives
yeah,
of this as well.
thanks very much.
Of course, yeah.
Thank you.
This was a ton of fun, Demis.
Thanks, Logan.
Thank you for taking the time to sit
Awesome.
down. I appreciate all the late nights thinking about the future and all the hard work that you and the rest of the DeepMind team are putting in. So it's been a ton of fun.
Great. Well, great chatting.
Likewise.
Thank you.
And thanks for watching Release Notes, everyone. And we'll see you in the next episode.